Okay, we're doing triangles. We just soldier on. Okay. Last time we proved if you put in the middle point, those three lines get to the same point, right? We just keep on working this stuff. Still the middle point. We have a triangle. Okay, still get all the middle points. This is probably anyway. Still get middle points, right?
Okay.
This time we draw a vertical line on this middle point.
Uh-huh.
This draw vertical line. This draw a vertical line. This draw a vertical line. Okay. Yeah. We're gonna prove these three lines come to the same point.
Okay.
This one actually is easier after you get the last time. We're gonna connect this point. In other words, we're gonna draw vertical lines. We make sure this and this is equal. This and this is equal.
Yeah.
Then these two lines point to a certain place. Then we're going to drop a straight vertical line down here. We're going to prove this one equal to this. Same thing.
Okay.
Okay. So we're going to draw some lines. Draw this line. Draw this line. Connect this line. This needs some improvement. Anyway. Okay. Okay. So we know this is the right angle, this is the right angle, and all those things equal, right? Look at this triangle.
Yeah.
Yeah, what can you see? They are congruent.
So what?
They are congruent. They're the same. This triangle
Yeah.
and this triangle. This side is equal. They share this side.
Yeah.
And they share the, they don't share the right angle, but these two triangles, that means these two right angles are congruent.
Yeah.
This is equal to this. That's SAS. Right? That means this side, this equals to this.
Yeah.
Yeah? Okay. Now, this triangle and this triangle have the same thing going.
Yeah.
So this is equal to this.
Okay.
Now you have a triangle with a straight angle.
Yeah.
You share this side, and then this side equal.
Yeah.
We just said ASS doesn't work, right? Wherever. We said ASS doesn't work.
Yeah.
However, if the right angle, it works. This is such a situation. This is the right angle. This is a side. This is a side. And actually, it just flipped over, right? So this triangle and this triangle and this triangle congruent.
Okay.
That means this side equals to this side.
Yeah.
And it's proven that way.
Okay.
That make sense?
Yeah.
Okay. Moving on. We're going to prove you have a triangle, right? You have a triangle. I'm going to drop this height, right? This is the height. I'm going to turn the paper because I don't draw very well. Just so I draw better. Drop this line. Drop this line. Okay. This meets at the same point. if I drop a vertical line from these points, these three lines meet at the same place.
Yeah.
Okay. You probably can't. There's no way you're going to try this probably. So I'm just going to tell you how this is done. Right? So you just follow it. I'm going to draw the parallel line parallel to this, parallel to this on all the sides. Okay? So I'm going to draw this. This is easier for me to draw. Draw this line. It's parallel to this.
Yeah.
Draw this line parallel to that. Parallel to that. You draw a line parallel to this. Okay. Now you draw this bigger triangle. Okay. Have I proved it? Have I proved it already?
What?
Have I proved it?
Prove what?
Prove that these three lines meet at the same place. Okay, let's refresh this business we just did, right? Let's refresh the business we did. We proved this, right?
Yeah.
We proved first we proved, what did we prove? We proved this, right? First we proved this, right? Actually, you don't need this because we're drawing parallel anyway. We proved this, right?
Yeah.
Compare these two triangles. Compare these two situations. Just do a compare.
Yeah, I know they're basically the same thing.
How are, in what way they're the same?
It's a triangle and but like these two triangles are
Oh no. You're talking about this triangle and this triangle. No. This is
yeah, I know.
yeah.
No.
You're talking about this triangle and this triangle. Look at another one. That doesn't work.
Wait, what did I talk about?
You said this triangle and this triangle are congruent. No, that's this and this obviously is not. That's just accidentally this side and this side is too similar. You know. Okay, let's look at this, right? You remember this?
Yeah.
When you draw a line that's parallel, right? Then you have these similarities.
Yeah.
Right? Here, I draw a line that's parallel. This is all parallel. So this triangle and this triangle got the same thing. This is parallel anyway.
Yeah.
Right? This equals to this. Do you see it?
Nope.
Okay. This is parallel to this. This is parallel to this.
Yeah.
So all of these triangles are, say, this triangle and this triangle are similar, right? Obviously, all angles are the same.
Yeah.
All you need to know is whether they're the same. You know, this is two parallel lines. This is two parallel lines. If two parallel lines and two parallel lines, you know what this shape is called? This shape.
Parallelogram.
Right. And in a parallelogram, what about this side and this side?
They're parallel.
And also,
Equal.
what about this? If this parallelogram, what about this and this?
Equal.
So this equal to this, right?
Yeah.
And this equal to this, right?
Yeah.
And this equal to this, right?
Yeah.
And this is the vertical. Oh, this parallel to this. So this line, the vertical to this, right?
Like
Right.
parallel to what?
If this angle, this is a right angle, and then this is a right angle also, right? Because this is parallel to this, right?
Sure.
And then this side equal to this, right?
Yeah.
All right, now let's take a look. You see any similarities here?
They're very equal.
There's the same deals, right?
Yeah.
So now what you have here is really, look at the big triangle, right?
Mm-hmm.
From the midpoint, right, you drew a vertical line.
Yeah.
Midpoint, you draw a vertical line, and midpoint, you draw a vertical line, right?
Yeah.
Are those three lines meet at the same point?
Yeah.
We just proved it, right? We proved it in this problem.
Yeah.
Yeah?
Yeah.
Okay. So we proved that one too, right?
Okay.
From this, you see one thing. That's how important these extra, well, I don't know what you call it, these extra lines, how helpful they are.
Okay.
If you don't draw them, it's very hard to prove it. But if you draw these, supplemental lines, right? It's very helpful. So much of the business is done in trying to draw these supplemental lines.
Mm-hmm.
If you can creatively come up with these supplemental lines, you can make a very complicated problem very simple.
Okay.
Let's just do one more. This one I'm not going to prove anything. Whatever you want to prove, you can think about it to prove. Anyway, you have a circle, right? I do very bad circles. Okay, we have a circle,
Yeah.
right? And then let's see. This is so bad, but anyway, you got the point. We connect these point, these point, these point. What can you get from these things? Let's connect these to help you look at this stuff. This is the tangent line, right? To this.
Yeah.
So this is the right angle, right? This is the radius. That's the right angle, right? This is the right angle. This is the right angle.
Okay.
The right angle, they share this side, right?
Yeah.
So this is equal to this.
Okay.
This is congruent to this. This is congruent to this.
Okay.
And there are business we can do about it, but we're not gonna do it. Actually the circle, we're not gonna do circle. I drew this just to make a point.
Mm-hmm.
Very often the interaction with circle and triangle is very important. And way back when I heard this, if you have a geometry problem, you don't know how to prove it, right?
Mm-hmm.
Try to draw some circles. I mean, a geometry problem with triangle, with lines, with straight lines.
Yeah.
If you can do it, you can prove it, try to draw some circles.
Okay.
If you have a circle problem of draw lines, that's kind of normal. That's kind of natural.
Right.
Okay. That's it. Bye.